Here's an example. A ball is dropped from a height of 320 feet. Its height after t seconds is modeled by the function
h of t equals negative 16. Bless you.
Okay. A couple of things we're going to do. Let's graph this bad boy.
What is it we're going to be graphing? What is this thing? Negative 16t squared plus 320. What is that? Say it louder. A parabola, because it has a t squared. Facing up, facing down, facing sideways. What is it facing? Down, because the negative 16 in front of the t squared makes it face upside down. So,
all right, it's going to be an upside down parabola. We talked about this last time. I know it's been about a week, but the most important part of a parabola
is, come on now.
Don't be shy. What's the most important thing to find on a parabola? The vertex. That's the first thing that you find. When it says graph and you know you're graphing a parabola, you best be starting by finding the vertex. So you actually don't really need to use the vertex formula on this or even complete the square if you're clever enough about knowing the equation of a parabola and transformations. But let's just assume for the moment that it's early. Our cleverness scale isn't quite high enough yet. Let's find the vertex. The formula is x equals the opposite of b over 2a. We don't really have x's, so I'm going to call that t. T equals the opposite of b over 2a. Well, come on. The opposite of b? 0. Why do you say 0? There's no middle term, yeah. So b is 0, and the opposite of 0 is 0, so it's 0 divided by, it doesn't really matter what we're dividing by now. It's 2 times negative 16, but 0 divided by anything is 0, so the vertex is 0, comma. And that you plug in a 0 for t. 0 plus 320 is 320. What I was saying a moment ago, though, if you were really clever enough, you could have just known that this 320 moves the whole entire parabola up 320. Is it my birthday?
No, but it is summer movie.
I don't think it's my birthday today. So sweet. We will in just a minute. We got to finish this. Now, you guys, another thing you have to consider is Yeah, put those in the back because people can't. Yeah, they wouldn't be able to see. We have to graph this according to its practical application. What does T stand for? Come on, T stands for time. So it doesn't make sense for time to be negative. So if we're going to graph this parabola,
It wouldn't make sense to graph this parabola using the entire xy coordinate system. Okay? We're only going to graph in the first quadrant here, because that's when time is positive. That's when t is greater than 0. Okay? Graph for t greater than or equal to 0.
okay. So
We have to label these axes correctly. The horizontal axis is t for time. The vertical axis is h for height. I'm going to label these by 50. So 320, 0, 320 is about right there. There's the vertex. Now I'm only going to want to graph the right side of the parabola because that's where time is positive. The parabola does have two sides, but the left side is where time's negative. It doesn't make sense to have negative time. So we know that 0, 320 is on the graph. We need a couple of other points. What about after 1 second? What's that? After 1 second, yep, it's negative 16 plus 320, so that's 304. 1 second's 304. Let's do a couple more. 2 seconds. 2 squared is 4. 4 times negative 16, that's negative 64. So 320 minus 64. 320 minus 64. Come on. Don't make me do all the work here, you guys. It's 320 minus 64. 256. So after 2 seconds, we're about 256. I want to be even more precise now, but instead of doing all the middle terms, I'm going to ask you this question. How long till the ball hits the ground? How long does it take until the ball hits the ground?
because what I want to eventually do is finish this parabola, but I want to know exactly where that parabola is when it hits the x-axis.
All right, let's talk about this. How do we answer this question? How long till the ball hits ground? How do we know? What are we solving for?
What does this phrase mean? How long? What is it we're solving for? Time.
How long till the ball hits the ground? We're solving for time. What's the height of the ball when it hits the ground, you guys? 0.
So we're solving for time when the height is 0. Solve for t when h of t equals 0. When h of t equals 0, that means the height is 0. It's on ground level. So you got to solve this equation.
Teachers, at this time, please release all students with the last names G through L for picture retake.
Okay, go ahead and solve it. You guys should be able to solve this one. This is like an Algebra 2 level easy quadratic equation to solve. So solve it. Subtract 320. You get negative 320 equals negative 16t squared. Then divide by negative 16. So t squared equals 20 square root, and t equals the square root of 20. Now, it's 2 root 5 if you want to be exact,
But let's kind of get our best estimate here. Square root of 20 is between which two whole numbers?
4 and 5.
So between 4 and 5.
about halfway between 4 and 5. We can estimate this maybe about 4.4. I don't know. So it takes about 4.4 seconds for the ball to hit the ground. So the parabola would look something like that. Or at least the half of the parabola that we graph, since we graph according to the context of the problem.
Okay, so when you're tracking the height of a falling object, taking into account just gravity and not wind resistance,
The height of a falling object is modeled by a parabola. Let's do something slightly different. Here's a new example. Let's say a ball this time is thrown. A ball is thrown from ground level. And let's say it's thrown by Colin Kaepernick. Ground level, straight up. With an initial velocity. Well, good morning. How hard do you think Colin Kaepernick can throw in feet per second? During the last game, the Broncos game on Sunday, moving to his left, he threw a ball 69 miles an hour of football. Moving to his left, that's pretty hard to do for a right-hander. I'm going to say, I don't know, I'm going to say 64 feet per second. The ball is thrown from ground level straight up with an initial velocity of 64 feet per second. The height of the ball after t seconds is modeled according to this function. H of t equals negative 16t squared plus 64t.
hopefully you notice some similarities in these two equations. Negative 16t squared, that's the effect of gravity here on Earth. 64t is the initial velocity. You learn more about this in a physics class, but
Question for this one is, what is the max height of the ball? Because unless this guy is Superman, the ball is eventually going to reach a maximum height and then fall back down to the earth.
Colin Kaepernick's pretty close to Superman status, except he stunk it up against the Broncos. But what is the maximum height of the ball? Well, what do you think? Not the exact answer. I'm not asking you for the answer is right now, but how do we find the answer? That's what I'm asking. Right there. Yeah. It's the vertex again. Because what is this equation right here? It's a parabola. And it's facing down. And what is this parabola modeling? This is important to understand this. This is not just a parabola. It is a parabola, but what is the parabola describing? How did I define this parabola? H means height. So the parabola is modeling the height. The parabola goes up, it reaches the maximum height, and it falls back down. So the maximum height would be the vertex. And the key word, you guys, in this section of your homework and on the test that you need to look out for is this word right here, maximum. Those key words, maximum or minimum, that should let you know that you're finding a vertex of some sort. So
I'm actually going to ask a follow-up question to this too. How long till it reaches its maximum height? So what is the maximum height? How long does it take to get there? All this boils down to is finding the vertex.
So again, I'm going to pause this. You guys find it. We've done enough practice of finding the...
Joe Montana used to do it. So I'm going to say t equals instead of x equals.
Some of you got it. I saw it on your paper. What is it? T equals... If you use the formula, negative 64 divided by negative 32. Come on, it's not a hard problem. You can do it in your head. 64 divided by 32 is 2.
Now, does this mean it reaches 2 feet in the air? What does that mean? It means the maximum height occurs at 2 seconds. So that actually answers the second question. It takes 2 seconds for the ball to reach the maximum height. So the ball is only going to travel upward for 2 seconds. Then it starts to fall. So that answers this question. What is the maximum height? How do we figure that out? How do we figure out the maximum height? Plug it into the height function. This is the height function right here, and we have a specific time value, 2 seconds, so you plug that into the function. H of 2 is negative 16 times 2 squared plus 64 times 2. 2 squared is 4 times negative 16 is negative 64 plus 128. So that's 64 feet. So whoever threw this ball, they were able to throw it 64 feet into the air. That's not too shabby. So you can expect a few of those falling object problems on your homework. Those are relatively easy, I would say. All you have to do is use the formula provided for you. You don't even have to come up with the formula. They give you the height formula. These optimization problems here, where are they? Optimizing. These ones are a little trickier because you have to come up with your own formula to use. So here we go. This is a very, very common optimizing problem. Anytime you're looking in a textbook about optimizing or optimization, you'll see a problem like this. So here's a new example. This is not the height of a falling object anymore. A rancher has 2,800 feet of fence. What does a rancher do? He ranches.
Is that even a verb? A rancher ranches?
A rancher keeps cattle, right? A rancher has 2,800 feet of fence with which to enclose a rectangular enclosure for cattle. The rancher wishes to build the largest enclosure possible using all
Please, students with the last
using all of the fencing.
What are the dimensions that yield the max area?
So what's the exact length and width that this rancher needs to build this enclosure that would yield the maximum area? And he's going to use all 28, maybe it's not a he, sorry. This person, it might be a she, is going to use all available fencing, 2,800 feet of fencing. The key word here, again, is this idea max area. We need to maximize the area. So, I've had students argue before that it doesn't matter what kind of rectangle you use, it's all going to have the same area if the perimeter is the same, and it's not entirely true. Just, you don't need to write this down, but I do want you to watch. Let me slide this over. Let's just say we had 28 feet of fence. Let's make this easier. Do you need to go? Yeah. Okay. Let's just say we had 28 feet of fence. What's a possible rectangle this guy could build? 1 by 13 by 1 by 13. Does that equal 28? What's the area then? 13. All right. Does that mean every single rectangle using 28 feet of perimeter is going to have an area of 13? What if he did 2 by 2? What would the others have to be? It would be 12. Isn't that the same available perimeter of 28? That's a perimeter of 28, right? But what's he now done to the area? He's almost doubled the area. What if he did 6 here and 6 here? Well, these have to be. So now he's got 6, 6, 8, and 8. It's the same available perimeter of 28, but now what's the area becoming? 48. So using the same amount of perimeter and changing the dimensions of the enclosure, we're increasing the area. So the question is, what's going to yield the maximum area? Okay. So what if we had a 7 by 7 by 7 by 7? 7, 7, 7, 7. The area of that is 49. How do we know that's the maximum area? So the key here is we have to prove it. That's the key here. We have to prove this using algebra and pre-calculus. So here we go. 2,800 feet of fencing is equal to the perimeter. Would you guys agree? Okay. What is the perimeter of a rectangle, though? Do you remember the formula? These are all geometry formulas. The perimeter of a rectangle is adding all the sides, right? So that's 2 lengths plus 2 widths. So now we could say that 2,800 equals 2L plus 2W. That's really all the information that we've been given, is that this rancher is going to use a perimeter of 2,800 feet of fencing, and that's equal to 2L plus 2W. The problem is, we're not trying to maximize the perimeter. We can't maximize the perimeter because it's going to stay constant at 2,800 feet. We're trying to maximize area. Area of a rectangle is equal to length times width. Here's the problem, though. That's not a function. A function has one unknown. This has 2 unknowns. We don't know the length, nor do we know the width. This is not a function. So, here's what we do. Let's use the perimeter. They wouldn't have told us the perimeter if we weren't going to use it. It's not just unnecessary information. Take this perimeter formula and solve it for one of its variables, either length or width. It really doesn't matter. Solve it for one of its variables. I'm going to solve for L. Solve
for L in the perimeter formula, that means you're going to subtract 2W. So we have 2800 minus 2W equals 2L. Divide everything by 2. And we have 1400 minus W is equal to L.
What was that all for? Exactly. We don't know the exact length, but we know the length in terms of W, so we can take this expression in terms of W and plug it into the area formula. That would give us a function in terms of only W.
So now you take this is what L equals, you plug it into here, and you get that area is now equal to, instead of length times width, it's 1400 minus W times W. That's a function now, because it only has one unknown. It only has the width. Let's clean this up a little bit. I'm going to just start calling it A. A for area equals negative W squared plus 1400 W.
Hey, look at what we have now. What do we have now? A parabola, and not just a parabola, it's facing upside down. Why did I say this was the key word again, the max area? The vertex, that's all this is. This is another vertex problem, because this area function describes the area in terms of the width. It's an upside down parabola, so the top of the parabola is going to be the maximum area.
So all we're doing now is find the vertex. So instead of x equals the opposite of b over 2a, we're going to use w equals the opposite of b over 2a. The opposite of b. Is there a b value here? Because somebody got confused on the last problem. Is there a b value?
Is it? Yeah, what is it? 1400. This is b because it has a variable associated. This is a linear term. So that's b.
So the opposite of b is negative 1400 divided by 2 times negative 1. So it's 1400 divided by 2, gesundheit, which is 700. Now, don't do any unnecessary work that you don't have to do. What is the question? What are you actually supposed to answer here? What are the dimensions? I didn't ask you what the maximum area is. I just asked for the dimensions that would provide the maximum area.
So, keeping that in mind, do we have to go any further with the vertex formula? What do you think? What have we found right here? What is this? Is that the maximum area? What is that? That's W. That's the width that would give you the maximum area. Okay.
So now you put that 700 into
Not in the original. Again, the question is only asking what are the dimensions. We found the width, so what's missing? The length. How do we find the length? Right here. The length is equal to 1400 minus W. If we know W now to be 700, so the width equals 700, and the length is equal to 1400 minus the width. But if the width is 700, then the length is 700. So which rectangle or rectangular enclosure would provide the maximum area?
700 by 700, which is a square. A square is technically a rectangle. Rectangle just has that 4 right angles.
So that's what I mean by proving it. How did we prove it? Because we found the vertex. Okay. If on a test this were a question and you just provided the dimensions of a square but you didn't show that you found the vertex, you don't get points for that. Okay? You have to prove it's the max area.
And how do you prove it's the max? because it is the vertex. There's no higher point on that upside down parabola than the vertex. There's a few other types of optimization problems on your homework. We don't really have time to go over all of them, but that should be enough right there. Yeah?
So, like, with this problem, you're always trying to find the maximum variance, but is it not always going to be like a perfect square? Is that like that?
It's not always a perfect square, unfortunately. Dang it. Well, we don't have time to go through the whole thing, but
Just consider this. What if it was the same problem, 2,800 feet of fence, but this time, for whatever reason, maybe there's some natural barrier like a ravine or something, I don't know, but what if, for whatever reason, this guy's only going to enclose it on 3 sides? So you're not going to have an enclosure enclosed on all 4 sides. There's some kind of a natural barrier, I don't know, a mountainside maybe. So the fence is only going to run on 3 sides like this. Do you understand the difference now?
that changes the problem. It's no longer going to be a square that would yield the maximum area. Does that make sense? That's why you need to show the process.
How would you start this? The perimeter is 1 length and 2 widths. You have an L right here, but you have 2 widths. So 2,800 now only equals 2L plus 1, or 2W plus 1L. And then you'd go through a similar process, but it turns out the dimensions are different. A maximum area would be a true rectangle and not a square this time. So just keep that in mind.